Hello there and welcome to this video. Today we'll be given an overview of the software GSS. So GSS is statistics software designed for non-statisticians. That means for everyday scientists which may have a profound knowledge in their area of expertise but may not have a master in statistics or data science. Or it's for students writing their master or PhD thesis for which they need to apply statistics without having much experience in statistics yet. Correspondingly, the idea of GSS is to make analysis and statistic testing easy and to provide some kind of guidance on the way. So at the end, we want you to know exactly what you did and why. Nonetheless, GSS includes a comprehensive set of tests and options which will satisfy also professionals. So in general, GSS covers the typical functions that most statistics software offers, such as descriptive statistics, statistical testing, charts, some other functions such as curve fitting, distribution fitting, or power analysis. But we also have a very powerful module for dose response analysis, which may be interesting for pharmaceutical scientists or toxicologists. When analyzing data, probably one of the first steps is to summarize data. That means to calculate descriptive statistics. You can do this here in the menu, Descriptive Statistics. Now you can select between all the typical statistics that are commonly used, and you can also calculate percentiles or confidence intervals here. The next step of data analysis is often to look at how your data is distributed. This is a very important step which should never be omitted because the distribution of your data is important for the selection of a statistical test. To fit distributions, choose Distribution Fitting here in the menu or press this button. Then select your data column and then we can select the type of distribution here in the list and press Fit. Now, if you also want to conduct a distribution test, such as Shapiro-Wilks or Kolmogorov-Smirnov test, you can check these checkboxes and press Fit again. This is one of the ways to fit distributions. You can also fit distributions or mathematical functions in the graphics tool of GSS, which you will see later. Filtering data. In many cases, you have a large data set with many columns. For example, a column with measurements and another column with further information, such as gender or education. When you want to compare different subsets of your data, you don't need to copy data for each comparison separately into GSS, but you can use data filters to do analysis more efficiently. We first have to make the filter visible. Here, show data filters, and now we can add filters. There are many options. Here you select the column for which the filter shall be applied. You can include or exclude rows. You can filter based on the value of a cell in your data table, if a value is equal, smaller or larger than a given number. And you can also use text filters to include or exclude data when a cell contains or does not contain a given text. For large-scale analysis, these filters are really useful. Statistical tests may be the part of statistics with which people struggle most. Here in GSS, we've tried to make a really powerful hypothesis module that makes statistics as simple and fail-safe as possible. First, we have developed a statistical guide which can help you to select an appropriate test. You can access it here in the menu, Statistics, Statistical Guide, or by pressing this button. Now here on the left, you can select which kind of analysis you want to conduct. Let's jump, for example, to the comparison of two groups. Here you can see a tree with two group tests, and just following the tree from the left to the right will guide you to the appropriate tests. Let's illustrate this with this example from a publication from McHugh. In this study, McHugh studied the effect of a vaccine on the proportion of participants becoming sick of a certain type of pneumonia. The research question is, did the vaccination have a significant effect on the number of people becoming sick? So the first question here in the tree is if data is paired or not. Assuming we are new to statistics, we wouldn't know what paired means. So we double-click on paired to obtain more information. And now there is a description of paired and unpaired data. We can just look at the short description here in this box. So for unpaired data, measurements between groups are not related. They are independent. We also see that unpaired data is the normal case. In contrast, paired data refers to the measurement between groups that are related to each other. For example, measurements in one and the same patient before and after treatment. In our example, we don't have such a case where measurements are linked between the groups, because in each group we have different patients. Now, if you still are uncertain, you could read more details here below. So our data is not paired. Now the next question in the tree is, if our data is normally distributed. To understand how our data is distributed, we have to think about what we actually measured at the lowest level. This is a key question. We measured if somebody was sick or not. That's our data, sick or not sick. And this data is simply true or false. It's not a value such as 4.5, so it can never be normally distributed. In any case, if you want to know more about normal distributions, we could double-click here and again obtain more help. So here we go for non-normal data. The next question is about data type. If you don't know what data type means, then we simply double-click here and check out how to distinguish data types. So nominal data refer to categories without order, such as red, blue or green. This may actually be what we have here. We measure the categories sick or not sick. There is no order. Now, ordinal data would be categories with an order. And metric data would be actual numbers, so we don't have that. We have to focus on what was measured in each individual at the lowest level, so that's not count, but we measured sick or not sick. So our data is definitively nominal. For nominal data, we can test for independence. And then in the next step, we have to check how many counts we have in each cell of our data table. We have relatively high numbers, so we definitively have more than 5 expected counts per cell, and hence we can use chi-square test. If you double-click on chi-square test, we see more details about the test, the aim, a description of what the test does, which data can be used. So you could check that out to be sure. And at the end, we also see this example. So this was a demonstration how GSS guides you through the process of test selection. The good thing is, when you conduct an actual test, you will find the same tree, the same structure also in the hypothesis test module. To conduct statistical tests, go to the menu and select hypothesis tests or press this button. Then here on the top, you can select how many groups you have. And then here below, you can see the same decision tree you saw before, only in a more condensed form. For each point, you get more background here below, the blue text. And if you still need more information, just press the question mark. Then you will see the same information you saw before in the statistical guide. You also have the option to show only those tests which can be applied for paired or unpaired data, or to show only those tests which can be applied for normally or not normally distributed data. Finally, you select your test and your data. Data selection is actually very flexible. In many software packages, you have to provide the data in a certain way that the software understands. Here you can use several different formats and you just indicate how your data is formatted. For chi-square test, you could, for example, use one of these 3 formats. Our data is already in the form of a table like this, so we just select the columns with our data and press OK. And now we press Show Results to obtain our test results. We obtain a short description of what the test does. Here below is our data in a contingency table, the typical form how data is presented for a chi-square test. And here below are the test results. This is the p-value, which shows us that there is a significant difference. And this is also expressed here below with this sentence. So this was an overview of the module for statistical tests. Curve fitting is useful to describe relationships between variables. For example, here we have a dataset with soil clay content and soil density, taken from this publication. To describe these data, we can do curve fitting by going to the menu and selecting Curve Fit, or we press this button here. Then we just follow these numbers from 1 to 4. So we first select which curves we want to fit. Then in the next step, we can adjust our settings. Then in step 3, we can conduct the fit or adjust the graph. And finally, in step 4, we can add the results and the graph to our results collection to save it. For this example, let's try different curves. And now we press Fit to see the fits. If we are happy with the results, we can add them to the results collection. Here we collect all results that we want to keep for later. Dose response analysis refers to the analysis of dose or concentration dependent effects. For example, the effect of a pharmaceutical or a toxic substance. Here are some typical dose response data. We have different doses, a mean response, the standard deviation, and the sample size per dose group. To conduct the dose response analysis, we go to Statistics, Dose Response Analysis, or we press this button. And then we select the type of data. We have continuous data, because we measured weight, a continuous variable. If you're unsure what kind of data you have, just click here. And if you need more support, click on the links here below. When we click OK, we already see our data in this graph here. Now we can select a dose response curve from this list on the left. We can also select several curves at once if you hold the Control key pressed while clicking, and then we press Fit. We also have some additional options here in the middle to calculate confidence intervals or to exclude outliers. In GSS Pro and the dose response version of GSS, you can also do model averaging or compute confidence bands. There are many more options. Here below you find the details of your dose response analysis. The level of detail depends on your settings. But for example, here you see various measures of goodness of fit, and here below are your EC values. Now we have already seen how to conduct curve fitting. Often when you do curve fitting or regressions, you may ask yourself if two variables are correlated. Maybe you have seen in the plot that there seems to be some relation, but now you want to test it using a statistical test. In GSS there are two ways to do this. The first is to use curve fitting and activate the test which you want to conduct. So I'll just use the data from this example and I'll choose a linear regression. And now here you can select which correlation test to conduct. Let's choose Pearson and press Fit. Now here we see the result of this correlation test. The variables are significantly correlated. The second way to do correlation tests in GSS is to use the hypothesis test module. If you think about it, correlation tests are in principle two-group tests, because we want to compare two variables. However, we are not interested in a difference between the variables, but in the correlation. And now here we can more clearly see when to use which correlation test. For example, for normally distributed data, we use Pearson. And we obtain the same result as before. GSS includes a graphics module to produce scientific graphs. To open it, go to Tools, Chart Designer, or press this button here. Now you first add data and then you select which type of graph you want to use. And now we specify which columns refer to the X and the Y axis. We'll use these data here, and we could also add error bars if needed. Once we have this graph, we can also conduct curve fitting here. We just select Add Fit to selected series, and now there are a lot of functions that you can choose from. Let's just use a linear fit for this data series, and let's use a quadratic function for the second series. Now you can adjust your graph as needed, change colors, fonts, transparency, etc. To obtain an impression of types of charts that you can create with GSS, check out our chart gallery. During a statistical analysis, we often conduct many tests and only want to decide later on which ones to keep. So it is good to have a way to store important results when you obtain them. I'll show you how to do this in GSS. When we obtain results that we want to keep, we can add them to the results collection. The results collection is a separate sheet here between our data sheet and our report sheet. So when we do an analysis which we want to keep, we press the button Add to Results. Then later you can find all of these results in the results collection sheet. Here below we see all the analysis which we have added, and the details of each single analysis, for example a test or a curve fit, can be accessed here on the top. We can still adjust the style of graphs, and you can save charts in various image formats. So here we collect all analysis which we may need later on. At the end of each analysis you may want to save your results in a file. You can do that by saving the results in the report. So just go through the results in the results collection and use the button Add to Report for all results which you want to show in the report. Later you can save this report, or you can add personal notes to the analysis here in the report sheet. There are some more functions in GSS, and we can't mention all of them in this video, but I'll mention two of them. First, we have a power analysis tool, which you can use to test the power of a test which you conducted. This can give you an impression of the meaningfulness of results from statistical testing. And second, GSS also includes a Monte Carlo calculator, but we will not go into details here. In the Pro version you also have some additional features, such as the calculation of minimum detectable differences or automatic testing over many variables in one step, and the creation of summary tables. So this was an overview of the statistics software GSS. If you have any questions, please write us an email. And if you liked the video, please like, share and subscribe.